All right, class. Today we're going to be learning about batteries. So, who knows what a battery looks like? You do. Can you tell me something about a battery?
It produces electricity.
It produces electricity. Anything else? Yes.
Positive and negative.
Positive and negative. All right. So today I've brought for you a battery. Who here believes that this is a battery?
No.
You believe me? Okay. So to test it and see if it's a battery, I have some copper and I'm going to plug it into the battery, and then I have some zinc and I'm going to plug it into the battery. And hooked up to the copper and the zinc is a light bulb. Now, if it was a battery, would it turn on?
Yes.
Yes. What happened? Did it turn on? No, it didn't. Now, why is that? It's not powerful enough. Exactly. So what I have here, I have more potatoes. More battery, exactly. So what I'm going to do is I'm going to plug this into here, and I'm going to plug this into here. Now, could you get the lights for me, please? Now, if I have set this up correctly, it did not set up correctly. Okay, sweet. It came out. Makes sense. Sorry about that, Professor. Now, what happens now is it did not. Technical difficulties. Sorry about that. Did it light up? Yes. So who believes me now? Is this a battery?
Yes.
Yeah.
All right. Now that's actually a very big problem. Is the potato is not a battery. The potato is not a battery. So what happened? Can anyone tell me what happened? We got tricked. Exactly. So when we plug in these two, right, we create what's called an electrochemical circuit. Now, what does it take for a light bulb to light up? Electricity. So, can you tell me what type of what type of energy is being produced based on the name electrochemical circuit?
Electrical.
Not chemical energy. Exactly. So what's happening is the zinc and the copper that we plugged in, the copper attracts electricity a lot more than the zinc. So when we plug them in and connect them with wires, electrons flow from the zinc to the copper. Now why is that? If we just took these and we just did this, does the light bulb turn on? No, it doesn't. So what's happening here is the potato juice is actually creating the reaction. Now, why is it important that it's potato juice and not, let's say, vinegar that's doing it? What's important about potato juice? Potatoes are actually very, very slightly acidic. Now, when you bite into a potato, do you get burnt by acid? No, it's actually only slightly acidic. It's 5.9, which if you remember from Professor Nick's class, what's neutral? 7. So if it's at a 5.9 or basically a 6, is it basically neutral?
No.
Pretty close.
It's very close to neutral. Yes, exactly. So what's happening is because it's reacting with the zinc, it's actually creating electrons, but it's also creating hydrogen atoms that are positively charged. And those positive atoms, those hydrogen atoms, are working their way to the copper, which is called the cathode. The zinc is called the anode. And what's happening is that the copper is then reacting with those positive atoms and creating hydrogen gas. So you'll see is, bubbles forming. Now, why is it important that, we have both of them plugged in? This is what's called a closed circuit. Now, if you think about, last lesson when we learned about closed circuits, is it important that everything's plugged in?
Yes.
What would happen if we just unhooked it? It would not. So when we close it all together, the electricity flows from this one to this one to this one to this one, and they all connect and they add their voltage together. And the voltage is about 2.6. Now, what makes the potato, sorry, read that one. What other common fruits and vegetables can we use to make a potato? Or sorry, not to make a battery. A lemon. Wow, where'd you get that idea? Anything else? A lime. So basically any acidic fruit or vegetable you can use, like let's say an orange or an apple, you can use to make a battery. Now, would the size of the potato
1 minute?
impact how the battery is affected? Would it produce more electricity, less electricity, or the same? Everyone thinks the same. So it actually produced more. So the difference between this one and this one is that when all the potato juice has made the reaction, it's used up. So when you have a bigger potato, you have
More potato
more
juice.
potato juice. Exactly. Now, why aren't we going along with these potatoes? These are obviously very efficient, right? Why don't we use these in our phones? They're big, they're not powerful, and they don't last very long. Alright, so we're gonna experiment with these. I'm gonna hand out potatoes. Please don't eat them. If I see any bite marks, they're coming back to me. And we're gonna experiment with in series and parallel. These are right now in series. We'll figure out what in parallel means. Thank you very much.